Alright, so in the part 2, so far we have seen how asynchronous programming works in Python, how we create coroutines, how we make tasks, how we make them concurrent, how flow from one thing pass on to the another thing. So we have discussed these things in detail. Now it's high time to discuss the event loop. So let's start with going back to little basics and then jumping over to the event loop. We have seen that in the case of multi-threading, we can create multiple thread, but each thread, if they want to run, they have to get GIL. Thread waits to acquire GIL. Okay, so the thread that have GIL on it, that thread can only execute. So only the thread that is having GIL, only that thread can execute. So it's kind of only one thread is running at a time, even though our CPU is having 4 cores or multiple cores. So this is multi-threading. Then we switched over to multiprocessing, where each process have its own GIL. This have its own GIL, this have its own GIL, but they can run simultaneously. But it is utilizing the multiprocessing module, utilizing the multiple core of the CPU itself. Now let's come over to the async IO, so that we can have one thread running, and this thread can work for something, then other thread, like it can execute some other thread and then come back to the previous thread when IO operation of this thread. Let's say it was making some DB call. When the DB response is returned, it will come back to the same thread, and in the meantime it will complete this blue task. So this is what we call concurrency with the help of asynchronous IO process. Okay, now the question is, what is event loop? So okay, so let's talk about event loop. All right, so event loop is basically a loop that keeps on checking whether there is a new task. So it checks if there is a new task. If there is a new task, so it will execute on the basis of its availability. So it will execute, and or it can like, obviously before, like when there is a new task, it will add into the queue, and from the queue it will execute whenever in the like your task, if there is some IO call or file call or some any other like sub process call can be there, so it will send it to the wait queue. And because it is our loop, it is our event loop, so it will keep running whenever it will see like there is this wait queue, the like IO operation have been returned by the OS. So OS listens. OS, now it is the duty of OS to check whether the operation, whatever the file read, IO process have been completed or not, and it will send a callback to our event loop. It will send a callback to our event loop. Okay, so event loop will register it, and in the next iteration it will complete the pending task. So for example, this wait queue had some items, and they went for the IO call, so it will like OS will tell, okay, the IO call is done, so it will pick those tasks as well. So what happens in event loop is, let's say we have a new task, so new task will come, it will get it will be like get added up to into the queue. Okay, so we will be having a task queue in which new task will be added. So let's like this, there will be multiple tasks. So whenever the new task will come, it will get added into the task queue. Then event loop, each kind of a loop that will keep checking whether there is a new task in the queue or not. It's like continuous loop, as the name is always also suggesting, continuous loop that checks if there is a pending task or not, if task is there to execute. Once there is like this event loop find out that there is some task in the queue, it sends it for the task submission. Then what happens is, this task internally can be having for example some IO call, some API call, or it can be having some sub process call, like you are running some command and you're waiting for the command to give the output as a sub process. Okay, or there it can be some file read. So these type of things, what this event loop will do is, it will send these things to the OS, and OS will monitor whether they are done or not, and it will send this particular task into the wait queue. So wait queue is another queue, all the tasks which have some IO calls, IO bound tasks, are sent to wait queue till they complete each IO bound calls. Okay, and this event loop will go on to the next task. So what happens is, when OS, operating system, will indicate to the event loop, it's a kind of a polling operation. When OS will indicate to the event loop that that the item that were in the queue, the IO process of those tasks is completed, so it will move the item from the wait queue to task queue. It will start the task again and complete them, and this process keeps going on again and again. This whole cycle is the event loop. The new task will come, task will get added into the queue. Event loop keeps on checking whether there is a new item or not. If the task is there, it will go into the task submission list. Task might be having some IO calls, so OS will indicate, like basically event loop will add that into the wait queue, and OS have to indicate to the event loop like there is some new task, there is some old task that is already like completed the IO call, so you can pick up and resume it. So event loop will move that task from wait queue to the task queue, and it will, like, on the basis of its scheduling, it will start the task and complete. And this happens for every task. So this is your event loop. Okay, so as you can see here, we have multiple tasks here. So it will the event loop will pick and execute. It keeps on checking. So all the IO bound tasks, like all the await call, will go to the OS, and like it can be file, it can be some network or CPU bound call or any other thing, and once their success, it will come back and callback will be added here. For example, like we have to reprocess the things. So event loop can do these things. Basically, it executes the coroutine. We know what's the coroutine is for any function that have async in the front, and we call it by the await. It executes the callbacks also. For example, like once the IO operation is done, OS will give a call back to the event loop, like that this process is done, please pick it up. So it executes the callback, it performs the network IO, DB query, etc., API call, etc., run the sub process. For example, we have to restart the Apache, so you can call flow service restart Apache 2. So this call you can wrap in the sub process and send it to the edge, and this call will run asynchronously. Because why to wait, like keep blocking the program? Because till this command is executing and do some work, what we can do is we can do something else. So basically, in this diagram also we can see the tasks are getting added into the event loop, and shows the task for like some IO calls, network call, or some delayed call, and it will like the OS will add a callback to the event loop that this particular task is done, please resume it. Check if the IO event complete, add read write handler to the loop. We'll see these things in more detail, but I guess you understand how once some IO call comes, the task goes to the OS, it execute, and it sends the call back to the event loop. Okay, this is the like important thing. So as you can see here, central part of our this diagram is what? Event loop. It is responsible for picking the task from the task queue, executing them, and handling the flow of control between different tasks. The event loop picks tasks from the queue, execute them until they hit either they hit the await, or they completes, or they are done, and either waits for IO call or moves to the next task. Okay, otherwise if the task is done, it will move to the next task. So event loop continuously run. It's a loop, correct? Executing a pick and execute the task, handle the IO bound and CPU bound operation, and coordinate the overall program execution. So this is your event loop. So to summarize, we create an event loop. How we create an event loop? So let's talk about this also. Let's say we have a Python code. Okay, so for example, here we have this Python code. In this Python code, we are creating this main method, and we are running the main method. So basically this main method is the entry point here, because we are running it with the help of async io.run. So this method is creating the event loop. So we can create event loop and we can get the previously running event loop by get event loop. Okay, this method. So async io.get event loop. So let's say we have a main program, and it already, because main program runs on a main thread. Okay, And event loop also like start on the main thread, the main executing thread of the Python program. So and if we don't have the main or some entry point, we can create new event loop with the help of new event loop method. There is event loop creation, then the tasks are added for the task submission, then we iterate for each task. If there is some IO call is done, so it posts the task and send it to the OS. It will poll for IO completion whether the sent tasks are done or not. Then it wake up the post task once the OS suggests that it is done, the previous IO bound task is done. So it will post the task execution continuation, and like it will complete the task and after executing it, and then it loop back to the new task. And this whole is the event loop cycle. So one other thing that I want to tell is when we run the main call, how event loop and the main or like Python main program works with each other. Okay, so whenever you run any Python program, so the interpreter will make a main thread. So this main thread will be responsible for executing the main function or any synchronous or asynchronous task that will come later. So this will be responsible, this main thread will be responsible to execute the main function and any asynchronous or synchronous task that will come later. Our event loop also runs in the main thread. Okay, so, and it handles all the like callbacks or IO operation, etc. Okay, so what happens is, like, we have this run until complete. So this event loop will keep on running until all the synchronous, asynchronous, or any other coroutine are completed. So as long as the event loop is running, so it keeps control of the main thread. It performs the task scheduling, IO handling, or any other like callback execution. And the main thread is essentially hosting our event loop. Okay, we can run other threads also, and for that we have this concurrent.future module. Okay, that have like thread pool executor and process pool executor. Okay, to make multiple let's say we have to create some separate pool, okay, separate thread. We'll import the async IO. We will create a main method and we'll call the like main with the help of event loop. Okay, so we import the async IO. We have defined the main method, and in the main method we have just the slip call, coroutine that completes after a given time. So it's also a coroutine, correct? Because async IO.slip is called by the wait. So this itself is having a kind of a blocking call. We have created a loop here. You can see how we create the loop with the help of new event loop method, and now we will execute. So we have seen this run until complete, the main method only, and finally once the main is completed we will close it. So we have this code block, so we can print what comes into the loop. So to execute, so you can see we have this Unix selector event loop. So we have again added our delay method that we previously created in the past videos, and we have imported the async IO. Now let's import a call later that we will call with the help of call soon. So async IO have a call soon method that runs actually on the loop. So loop.callsoon, that what it do is it will take a coroutine that, or it will take a function that will be executed in the next iteration of the event loop. So we are defining a main method, and in the main method we are like having a where we are getting a loop whatever it was running, because now we have the main method and we will run the main by async IO.run. So it will already be having a running event loop, and not like this where we are creating a new event loop. Okay, and we'll adding call soon with a call later. So call soon, like call later will be called soon in the next cycle, and we're adding a delay of 1, and then we call the main. So you have to find the difference here, that because we are not having any run to the main, that's why we were not having any event loop there, but now we are having the event loop and we're getting that event loop only. All right, so this is how we can get the event loop. All right, okay, so what happens sometime is that event loop can keep on continue like waiting for the task, and the task is not getting finished. So in that case what we have to do is we have to use timeout. Okay, so how to use the timeout is So I'm commenting all of these things out again. Okay, so what we'll do is we have a task one that have two print statement, and between have a sleep of 2 seconds. Then we are defining a task 2 with a sleep of 4 seconds, same thing like task 1. Then we have a main method with try block, and we will then execute task 1 and task 2 that we have defined. Once again, so now what we are doing is async I.wait for. So what wait for do is it wait for any like future, or like what is future, by the way? Future is anything that whose value will come into the future. It's like, let's say something will get executed later on, so we call it future. It's like same thing, we have promise in the JavaScript. So wait for the single future or coroutine to complete. Okay, coroutine will be wrapped in the task return result of the future. So future, like let's say I don't know what will the value of a particular function after its execution, so we can say it's some future object. Okay, that's like how it is. Now here we can add the timeout also. So in what we have done is we have called async io.gather. So like we can add multiple tasks with the help of async io.gather. It's like how we were doing thread.join individually. So the async io.gather is actually doing the same thing. So returns a future aggregated result from the previous coroutines. So coroutines will be wrapped in a future and scheduled in the event loop. Okay, so we have passed both the task, and we are saying like the total timeout is 3 seconds, but you see the task 2 will take 4 seconds. Let's see. And now we have to like catch the async io.timeout error, and then we will run the main. So let's run it. So you see task 1 started, task 2 is started, task 1 finished because it have like only 2 seconds, but task 2 was not able to finish, so we got this execution limit reached and task cancelled. So this is how you can add the limit in the task. Okay, now we can improve our main method little bit like this. So we will like accept one more error, like runtime error or something that can happen in the like this all that I'm telling is like how to handle exception handling in the event loop. Okay, so we have the so here you can see we have the main method, and here we are again running both things async io.gather, but we have used wait for. So it's like we are waiting for this task to be completed with a timeout of 3. It's like previously, but now we are accepting the timeout error as well as runtime error. Okay, so if there is an error in the task, it will give the problem. Okay, but in our case it will be like timeout error for now. Okay, task timed out came. So here one of the most important thing to note is this async io.gather. Okay, so this async io.gather is the thing that helps to run multiple coroutines concurrently. Okay, this is not doing it sequentially but concurrently that we require. Okay, as you can see here, when task 1 started, task 2 also started, and task 1 finished while task 2 was also like waiting for the timeout. So this whole thing was happening kind of in a concurrent manner. Okay, so that's all right. So let's take a final example for our async io and event loop to make it a kind of a real-time thing. So basically what we have to do is, let's say we have to implement a web scraper that will scrape multiple websites, and it will store the results, and we have to create multiple tasks, and this scraper will read multiple websites simultaneously. So what we have to do is we have to import async io and AIO HTTP package. So for that we have to install it also. So pip install. So this is like asynchronous HTTP client server package that helps us to make like requests, etc., and also it supports WebSocket, and it's like kind of quite advanced. If I say we installed it. Okay, now let's import the async io and HTTP. Then we will define the websites that we want to scrape. So list of websites that we want to scrape. And okay, so let's say we have Air India website that we want to scrape. For now we are now defining the fetch website coroutine, and it will get a URL and the session. So in the try block we have added like get the URL as the response, and if the status is not equal to 200, that means there is something with the page, some issue with the page. Okay, otherwise we'll convert, like we'll get the text response and we'll return the content. And in the exception we'll add timeout error and any other general exception. So this is simple method fetch website. Now we'll define another method like to scrap the website. Now this is like for a particular website. Now to scrap all the website and make individual coroutines. So for that we have included a HTTP and the client session, and we will add the task in this list. So for each URL that are present in the website list here, we will call the fetch website. Okay, so we are creating a task and calling the fetch website. So here you can see how we are doing this with the asynchronous programming. Like we are not calling individually, but we are making particular task. Okay, and they will run in parallel. Okay, all the websites. Then we are appending this into this task into the task list. Then we can like set the timeout. So we are like for all the tasks that are there, we have to execute like at this stage we have just created the task, we are not executing it, and now we executed it by unwrapping this and passing into the async io.gather as we saw here. Okay, in this case like async io.gather, and we pass all the tasks to help run the multiple coroutine concurrently. Okay, so this is the same thing, and if there is timeout error we will stop it. Finally we have to run the scrapper, so async io.run and this function. So this is your scrapper implemented. So the main idea that you have to understand here, like how we create like how we fetch the website multiple websites by creating task for each, and then async io.gather runs those coroutines together. Okay, and then saves the response. That's the whole idea. So in this code block we have added the timeout, we have added the exception handling, async io.gather, wait for, create task, all of the things that are like very common when we do the asynchronous programming. Okay, thank you.